Today we're going to talk about two more GD&T symbols, that being circularity and cylindricity. And it's very similar to what we talked about with straightness and flatness, where straightness was just any cross-section, looking at how straight it was, and then flatness was looking at a whole surface. So it's kind of the same thing with circularity and cylindricity. We're looking at a cross-section of a cylinder and how circular it is, and then we're looking at the entire cylinder and how circular that is as well. So with circularity, that again is pretty much a cross-section. And we basically want to control the roundness of the shape by using this. We're going to have a tolerance zone of 2 concentric circles. So when we talked about the straightness of a feature, a cylindrical feature, we were applying it to the axis, and we were talking about a cylindrical tolerance zone around the axis. So now we're talking about 2 circular tolerance zones and around the actual circular surface itself. So we don't use the MMC or the LMC on this one. It's obviously got to be a circular diametral object. And the tolerance itself must be less than half of the diameter tolerance. And what we'll typically see is a percentage of the tolerance. So it might be like 20% of the tolerance or 30% of the tolerance, something like that. So you have to do a little bit of calculation to figure it out. So it's not a feature size, it's just a surface control, kind of like straightness. So it's just going to point to a surface or circular shape, not be attached to the dimension itself. So if you take a look at controlling the circularity of this cylinder here and taking a look at a cross section, if you take a look at all 3 of these would actually be allowable parts because they all fit within the zone. So obviously you can get pretty far out of round on some of these, so we could use a tighter tolerance to control that. This is of course blown up as well, so that you can see it. Important thing to note here, this 0.3 is not a diameter value, it's actually the distance between the 2 zones. So I don't want you to think that it's a 0.3 and we got to divide that by 2 and we've got 0.15 on this side and 0.15 on this side. It's actually saying at any given point we've got a 0.3 tolerance zone between the smallest and the largest. So if we take a look at another circularity here, if we take a look at the tolerance itself, it's 0.006. And in this case, the size tolerance, if I were to, that I would divide by 2 because this is the full cylindrical shape, can vary 0.006. So if I wanted to compare the top versus the bottom, then I would divide that by 2. And I could have 3,000th on the top and 3,000ths on the bottom. Because again, if we look at this cylinder as being 0.994 and this one being 1, then to split that I would have a tolerance zone of 0.003 above and below. But as you can see, our circular tolerance is tighter. That's the whole purpose, is to control that a little tighter than what our standard tolerance does. I'll pass that assignment there. So any questions about circularity? I think it's pretty straightforward. We're just controlling the circularity, and this is the distance between the 2 circular tolerance zones. All right. So cylindricity, again, it's kind of like straightness versus flatness. We're now looking at the entire cylinder, not just any cross-section of the cylinder. And we want to control the tolerance zones, and this time instead of just being 2 circles, it's going to be 2 cylindrical planes. Once again, no MMC or LMC, and it's got to be a circular shape, and it's got to be less than half the diameter tolerance. So this is the symbol for cylindricity, a little circle with a couple of tangent cylindrical lines on it. This particular one, you can point to the circular view or the cylinder view. So in the case of circularity, you've got to point to the circular view. But on the cylindricity, you can point to either one. Not both, that's over-dimensioning, but one or the other. And again, now instead of controlling just the circular shape, we're also controlling it the length of the cylinder as well to keep it within the specified tolerance zone. So, keeping it a little simple today, got 3 exercises for you to apply circularity and cylindricity. And say that again.
Do you need our book for the exercise?
Actually, the instructions I think are on the sheets, so they're the same exercises that they are from the book, but I believe all the instructions are on the sheets too. So let's look at those. So these are in the 1612 folder. We're just going to do the first three. So 16-231. Yeah, the instructions are here. So you've got some dimensioned cylinders here, and you are to add circularity tolerances to the diameter shown below, and those tolerances should be 1/5 of the size tolerance. So for example, don't worry about this one, this cone shape, but just look at these three cylinder shapes. So if I look at this first one, its total tolerance is 0.25. And so the tolerance is going to be 1/5 of that. So 0.25 divided by 5 is 0.05. So I'm going to create a circular tolerance zone of 0.05. And then create a leader to point at that surface. So that's all we're doing on the first one. So 3 different circularity callouts.
So you don't have to put the diameters in.
I believe that's correct. Yes, because
It has to be a circle anyway. So.
yes. Yeah, when we apply it to the axis, we apply it. Yeah, that's a good question. It is a circular shape, but they don't require the diameter symbol. I guess maybe because it's 2 circular shapes. I don't know. That's a good point. But you only apply it when we're applying it to an axis, and that's making the circular shape. Yeah, good question. But nope, not required. All right. Let's look at the second one. It's going to be similar, but this time using the cylindricity. So again, the big difference is, aside from the symbol change, you can point to the circular feature or the cylinder shape itself. And 232. So for this one, we want to do cylindricity, and it's going to be 1/4 of the size tolerance. So take the size tolerance and divide it by 4, and that will be your cylindricity. So on this one, you're just doing the hole itself, not this outside shape. So you'll just have a call out for the hole. And again, technically, you could point to the circular shape or the cylinder shape, but since it's hidden in this view, you wouldn't point to the cylinder, you'd want to point to the circular. But then as we're taking a look at this positive cylinder, you could point to the cylindrical shape or to the circular shape over here. Either one would be fine. So cylindricity, 1/4 of that.
So can you apply the Cindericity or whatever thing to holes as well? Is that what you were saying?
Yes. Yes. But as I'm calling them out with my leaders, so this would be okay. And then I could put my cylindricity. This would be okay. And then, actually, I'll bring it down below. And I'll just get rid of this text here. Feel free to do that as well. So this would be appropriate on either one of these. Technically, you can point to a cylinder shape over here, but since it's hidden and we don't dimension to hidden lines, this would not be appropriate. All right. And then the third and final one, you're just going to simply evaluate 3 cross sections for circularity and decide if they are good parts or not. So again, we're not going to do the 4th one in here. It's pretty similar to the first 2, and this thing is going slow. There we go. Okay, so these are little tables. You can just double click in them and type, and really you can just put in yes or no if you want. So is this a good part? Is this a good part? Is this a good part? So you've got a circularity of 0.001. Do these dimensions fall within those tolerance zones? And remember, the 0.001 means 001 between the 2 circles. So not a total difference in diameter of the 2 circles, but just the tolerance zone right in here is 0.001. So if I've got .744 is my inside and .746 as my outside, would that be a good part? So keep in mind that, get back here, this is most likely not to scale. So if this inside circle is .744 plus .001 plus .001, that would be .746. So would this be a good part? Yeah. And that's where I think I'm trying to stress that the 001 is the difference on each side. So it's not going to say that these two values are .001 different. In fact, it's going to say it's .002 different because you've got it on both sides.
So whatever the tolerance is basically double.
Basically, because you got it on each side.
Okay.
Yep. So using that strategy, just give me yeses or nos in each of those boxes. And that's it for today, just those three. And I know some of you still need to catch up on some of the other ones, so I wanted to give you time for that as well. So let me know if you have any questions.